I want answers, I shall have answers.
I'm going to give you another way to find the solution to a linear system. Recall what that means. The solution to a linear system like this, one line is y equals 4 minus 2x, and another line is, say, 3y minus 2x equals 4, two linear equations. The solution to that system is a point, and in this case it's the point 1, 2, because it fits, and it's the only point that fits into both equations. Now it's easy to see that it's also the point of intersection, isn't it? Because it's on both lines. Now, take a look at this one. Forget the equations for just a second.
I know that, dude.
And consider that the point of intersection is the common solution here. The problem with doing it by drawing graphs is that you kind of have to estimate what point that is. Is it, how much did you go over and how much did you go up? Well, it's about
Houston, we have a problem.
0.4 and 1.2, but we are only guessing, you see. And we may want exact answers for our system solution. So, as you can see, graphing is not always the most accurate method for determining the solution, to find that point of intersection. There's going to be a second, much more accurate method of finding that intersection point, and we call it the substitution method, and it's not that hard.
Now I want answers, I shall have answers.
Let me show you how to find that point of intersection without even drawing anything using the substitution method. Here's how to do it.
Now you listen to me. I want details, and I want them right now.
I'm going to tell you exactly how to do it. You're going to get two equations, of course, right? Each equation has its own line, but we're not going to draw the lines. The first step is to solve one of the two equations for one of its variables, whichever is easiest. In other words, whichever is the closest to being alone. Now look at the blue x, the blue y, the green x, and the green y. My hope is that you can decide which is the closest to being alone. Take a look. Well, I'm going to pick the blue y in this case because all I'd have to do to solve for him is subtract 3x from both sides. I wouldn't have to divide or anything. So he's the easiest to solve for, and that's what I always pick. So I'll make life easy for myself and solve for the blue y. Now who's keeping him from being alone? The 3x, so I'll minus 3x to both sides. And I'll have y in that case equals negative 7 minus 3x.
Now what am I going to do?
Well, what you do now is take what that equals, that y equals minus 7 minus 3x, and substitute it, hence the name, substitute it into the other equation instead of y. And you see what you have now is an equation with only x's. Now with that equation that only has x's, or one variable, let's solve it. I'm going to put the like terms together that are on the same side. And let's see, I have to get x alone now. I'll subtract 35 from both sides. And I'll divide by 17 to get x alone. And in this case, x will be negative 2.
The important thing is it your final answer?
Now remember, I'm looking for a point of intersection. A point has an x and a y. So I still have to find the y. But I do have some added information here. I know what x is. Now I'm going to take that added information, that x equals negative 2, and I'm going to substitute that value back into either one of the original equations. I'm going to substitute it into the 3x plus y equals negative 7 because that looks easier to me. But you could substitute it into either one. So instead of x there, I'm going to put a negative 2. Well, now I have an equation with only y, don't I? And I can solve for y. Adding a 6 to both sides to get y alone, I get y is negative 1. Now I know the x, and I know the y. So the solution is the point negative 2, negative 1. Now why did I put the negative 2 first? Because he's the x, and of course the y goes second.
His brain is gone.
Oh, I'll tell you what. Let me plug it back into the equation that I didn't check it in. Always do that, just to make sure that it works in both, because if it doesn't work in both, it's not the real solution, is it? Put a negative 2 in for x and a negative 1 in for y. Let's see what we get. Negative 4 and a positive 5 and son of a gun.
The mother lode.
That does equal 1, so it works in both equations. Already tested it. So I found the solution to the system, without graphing, mind you, and it's exact. So, the steps to solving a linear system using the substitution method are: first, solve one of the two equations for any one of its variables, whichever is the easiest, whichever is the closest to being alone. Then take the expression that's equal to and substitute it into the other equation. That'll give you an equation that has only one letter in it. Solve for that single variable and take the value that it's equal to and substitute that back into the other equation and solve for the other variable. Then I suggest that you check your solution, your x and your y, in both equations. Okay?
That's all, folks.
Okay, give it a try. Try the homework and make sure you check, sissy on you if you don't check your solution every time in both equations.